Hello, in this video we're going to take a look at exchanging between exponential and logarithmic form of an equation. So an exponential equation, y equals b to the x, means the exact same thing as log base b of y equals x. Now on this, make sure that you are making that b as a subscript. So if we go back and use the lines that we used in kindergarten when we were learning how to write, we're going to get log is going to be full size, but that base is going to be a subscript on the bottom. And then our y is full size. Alright, so if we convert back and forth between these two, you can always start out at the base, go across the equal sign, and then circle back around. Start at the base, go across the equal sign, and circle back around. And that will give you your values in the order of the exponential or the logarithm, and then what's equal to the other side. So on this first one, we have 2,401 equals 7 to the 4th. So our base is going to be the number that is raised to the power. That's going to be the 7. So we're going to have log base 7. We're going to go across the equal sign. That gives us our argument of our logarithm. So 2,401 is what we're taking the log of, and that is going to be equal to the 4 that's in the exponent. One thing to notice is if two numbers are on the same side of the equation in one form, they will always be on the opposite sides of the equation in the other form. Alright, if we have 3.2 equals a to the 6th, our base there is the base of the exponential, the a, and that is, we're taking the log of 3.2, and our exponent is going to be the number that is by itself. E to the x equals 11. Here we're going to have a log base e of 11 is equal to x, that exponent x. Again, same thing works. Start with your base, go across the equal sign, and circle back around. But log base e is one of our special bases that we work with a lot, and so that's what we are going to call the natural log. And so we're going to do the natural log of 11 equals x. One thing that I do want to point out that I see students miss a lot when they're typing this in, that is a natural logarithm. That is an ln of 11. That is not an I, that is an L, and that L stands for logarithm. Alright, now let's go the other direction. So if we convert this to the exponential form, our base is going to still be the number that is next to our logarithm. So start with our base, go across the equal sign, and circle back around. This is going to be a raised to the number by itself, so a raised to the 7th equals 4. Our second one, we have log base 5 of 25 equals x. So we can rewrite that as 5 raised to the x equals 25. And the natural log of 6, remember just like we saw in the last one, the natural log of 6 can be written as log base e of 6. And so if we start at our base, go across the equal sign, and circle back around, we're going to get e to the x equals 6. Alright, the rest of these we are going to look at simplifying and evaluating without using a calculator. So if we have log base 9 of 1, we can kind of think of this as an equation, convert this to the exponential form, so log base 9 of 1 equals x. We could rewrite that as 9 to the x equals 1, and then ask ourselves, 9 to what power is equal to 1? Well, any base raised to the 0 power equals 1, so that's going to be x equals 0. So log base 9 of 1 equals 0, and that's actually going to be true. Anytime your argument is a 1 there, your logarithm any log, any base of 1 will always be equal to 0. All right, log base 3 of 27, if we convert that to, make that into an equation and convert it to the exponential form, we're going to get 3 to the x equals 27. And we know that 3 cubed is equal to 27, so x is equal to 3. All right, our next one, we have log base 1/5 of 125. So we're asking ourselves 1/5 raised to what power equals 125? Well, we can think of this as an exponential with like bases. 1/5 is the same thing as 5 to the negative 1. 125 is the same thing as 5 cubed. We've got them with the same base. We need to simplify that left-hand side. Power raised to a power, we're going to multiply those exponents. So we get 5 to the negative x equals 5 to the third. So that means negative x equals third, or x equals negative 3. We can do a similar setup if we have log base 8 of the square root of 8. We can think of that as 8 to the 1/2 equals the square root of 8. Remember, a square root is the same thing as raising something to the 1/2 power. So the square root of 8 we can write as 8 to the 1/2. Now we have like bases. That means that x has to be 1/2. Log base square root of 6 of 36. We can think of that as the square root of 6 raised to the x power is equal to 36. The square root of 6 and 36 are both powers of 6. Square root of 6 is 6 to the 1/2, and then we still have that raised to the x. 36 is the same thing as 6 squared. Power raised to a power, our left-hand side we can write as 6 to the 1/2 x equals 6 squared. And so 1/2 x has got to equal 2. To get rid of that 1/2, we're going to multiply by 2 on both sides, and we get x to the 4th. So that means log base square root of 6 of 36 is equal to 4. And then our last one, we have the natural log of the 12th root of e. Remember, our natural log is the same thing as log base e. And our 12th root of e is the same thing as e raised to the 1/12. So if we convert that to the exponential form, we're going to get e to the x equals e to the 1/12. We have the same base, so those exponents have to be equal, and x is got to equal 1/12. All right, I'll see you guys next time. All right, now let's look at using the calculator to evaluate a couple of these. So we have the first example we have here with the calculator is the natural log of 18/5 divided by 0.02. So when you enter this into your calculator, you want to make sure that you have parentheses around your numerator, parentheses around your logarithm. Make sure you close the parentheses that are automatically open. We want it to look exactly like it does here. Most of the TI-84 calculators will do the fraction in a vertical fraction like this. If you go to alpha, y equals, and then the first one you get is numerator n/d, that stands for numerator over denominator. So in our numerator, we have the natural log of 18/5. So ln, it's going to open that first set of parentheses for us, and we can do 18 divided by 5. Make sure and close that parenthesis before you divide by 0.02. So we get 64.05 is an approximate answer for that one. And then our second one, again, we're doing the same thing. We've got a fraction, so let's go ahead and use alpha y equals and get numerator over denominator. Our numerator is going to be the natural log of 12. Even though our problem doesn't have an open parenthesis there, we do need to close the parenthesis for that first natural log before we add the natural log of 4. Again, it opens that parenthesis for the log. We need to make sure and close it. And then on the bottom, we get, now this is an log, this is a common log, so we're going to use the log button. It opens the parentheses. We need to make sure and close that parenthesis on the 12 before we add the log of 4, and then make sure and close that parenthesis on the log of 4. And so this expression is going to simplify, or going to be approximated by 2.30. All right, I'll see you guys next time.